Okay, Assalamualaikum and a very good morning. I wish to all the participants today. My name is Nasri bin Semyon and today I'm going to be your moderator. I am from the Assist Vice Chancellor Office, Industry and Community Network, University Technical Malaysia Melaka. And for your information, this webinar series is under the Knowledge Transfer Program umbrella. It is one of the Ministry of Higher Education methods to transfer knowledge from the university to the industry. At the end of this webinar, the audience will receive a link to a feedback form. The audience who fill up the form will receive a digital certificate of participation, and those from UTM will given CPD points. Our topic today is SMT's stencil design for new SMT process engineer and will be delivered by technologist Muhammad Anwar bin Adi. Mr. Anwar is a teaching engineer at Faculty of Electrical and Electronic Engineering Technologies, UTM, who has 10 years of experience in the industry as a surface-mounted technology process engineer. He is also one of the certified manufacturing engineers at his company previously and is familiar with the IPC 610 standard. While in the industry, he was fully involved in the new product introduction project, starting from buying equipment, production lines layout, and all the documentation, introducing the product in the printed circuit board assembly. The main challenge faced when you're producing printed board assembly is to ensure that the printed circuit board assembly produced has high reliability because it will be used in a long-range fiber optic communication. Without further ado, I would like to invite technologist Muhammad Anwar bin Abdi to deliver his speech. Mr. Anwar, the floor is yours.
Okay, thank you, Mr. Nasri. Okay, salam and good morning to all participants today. Okay, thank you for joining. Thank you for joining today knowledge sharing session. Okay, so before we go into the topic, let me introduce myself lah. Okay, so my name is Muhammad Anwar bin Adit. So before joining UTM, I've been working in industry for 10 years. Okay, mainly on PCBA assembly process lah. Okay. I'm working in the contract manufacturing company at Johor Bahru. Okay. So for 10 years, I mainly do process engineer for SMT lah. So SMT stand for surface mounted technologies. Okay. So mainly my product is about fiber optic transceiver. Okay. Okay, fiber optic transceiver, which is usually used in telecommunication and internet networking for long range communication. Okay. Between 20 kilometers and 30 kilometers lah. Okay. So my customer is Cisco. Okay. Cisco is the end customer lah. Okay. And the company that produce the product actually last time is Avago, but I think now changed to Broadcom already. Okay, Broadcom or Foxconn are now. Okay. So I believe some of the participants today is coming from industry, right? So maybe maybe some of you can write, okay? Can write at the chat box, okay? What is your position now and from which company? So that I know who is the participant today lah. Okay. Okay, let me share my slide. So today this is the topic, okay? Actually, this is a very basic knowledge, okay? Usually new SMT engineer, okay, should know and should learn lah, okay. So this knowledge actually I get from my experience, okay, reading technical papers and learn from the seniors lah, okay. It may be correct, it may be not correct, okay, but this is what I learned from the senior, from my experience, okay. Okay, so we go to the basic first. Okay, the basic. Okay, surface mount technology. Okay, surface mount technology is a method. Okay, it's a method for constructing electronic circuit board in which the component, which is the surface mounted component, are mounted directly onto the surface of the printed circuit board. Okay, okay, as you can see, right? Okay, okay, this PCB is mixed. Okay, it's mixed between through hole component and the SMT. Okay, through hole component example is inside the red box. Okay, that one is the through hole component, which is if we want to mount the component, okay, there must be a hole to insert the lid. Then usually industry we will use wave soldering process. Okay, wave soldering process. And for SMT, right, usually we will do the solder reflow process. Okay, so it's a different process lah actually. Okay, usually we will do the surface mounted technology. We will do the SMT first. Then after that, we will do the wave soldering process or manual soldering process for the rated through hole component lah. Okay, or manual insert. Okay, we need to manually insert the PTH component. Okay, for SMT, usually we will use the surface mounter lah, surface mounter or chip mounter. We have so many kind of machine lah. Okay, usually in industry we have Fuji, NXT, Panasonic. Okay, all kind of machine lah. Yamaha also produce SMT machine lah. But I don't know whether they still have new model or not lah. But now most of the industry now use Fuji NXT, I believe. Okay, the machine is small and fast lah. Maybe can mount until 20, I think 20,000 component per hour. Okay, based on their data sheet lah last time. Okay. If we go to the next slide. Okay, so this is the basic. Okay, okay, the basic for producing printed circuit board assembly. Okay, the first process is the solder paste printing process. Okay, second process is the SMD part placement. Okay, and the third process is the solder reflow. Okay, so okay, the first process, the solder paste printing, is a process to apply solder alloy onto the PCB. Okay, or land pattern using metal stencil. And then second, we place the component, the chip component, the SMT component onto the PCB. After that, we need to reflow the solder paste. Actually, reflow is like cooking. We need to cook the solder paste to turn the paste from paste into solid metal. Okay, into solid metal, and make the electrical connection. Okay, so this is the process. Okay, this is the solder paste printing process. Okay, so actually you can see we have a machine. Okay, we have a machine. Okay, we have the solder pad, we have the PCB. Okay, and then we have the squeegee. Okay, okay, you can see. Okay, before and after PCB printing process. Okay, before we can see all the pad. Okay, the pad is the gold color. This one is the PCB, right? The PCB pad is made from the gold lah, unique gold. Okay, unique gold. This is the product that I produce. Okay, the pad is made from the gold. Okay. Okay, next. Okay, next. Okay, what is the SMT stencil or PCB stencil? Okay, tool or medium used to transfer solder paste onto the PCB. Okay, consists of foil made of stainless steel with a dedicated aperture according to the component on the PCB pad. Okay, so we have a stencil, we have a metal. Okay, a sheet of metal. Okay, then we mount the sheet of metal onto a aluminium frame. Okay, and the metal, right? Okay, and the foil. Okay, the metal foil. Okay, have a aperture lah. It's an aperture or opening lah. So all opening, okay, is dedicated to PCB pad. Okay, which mean if we want to have a solder paste on the pad, we need to make the opening at the stencil. So type of stencil. Okay, so in industry, right? Okay, we have many type of stencil manufacturing process lah. Okay, actually, this different type of manufacturing process for stencil is because we want to make sure, right, the opening is the most correct, and we have a very good solder paste transfer. Okay, actually the target is we have a very good opening and solder paste transfer, which means if the opening is 12 mil by 12 mil according to the Gerber, okay, according to our design, then when we make the opening, okay, we want to make sure also the opening is 12 by 12 mil lah. Okay, so the first one is the laser cut. Okay, laser cut with electro polishing. Okay, as you can see, as you can see inside the picture, okay, you can see, okay, without electro polish, okay, without electro polish, okay, the surface is more rough, okay, no surface treatment, okay. So with laser cut with electro polish, okay, the surface is more smooth lah. So we have better solder paste transfer lah. Okay. Okay, next stencil manufacturing process is the electroform or chemical etch. Okay, this one actually the opening is made by using chemical, same like we make a PCB lah. It's a etching process. Same like etching process. So we use a chemical to make the opening. Okay. Okay, laser cut we use a laser. This one use a chemical. So as you can see, right, electroform, the wall surface is smooth compared to the laser cut. Okay, that's why electroform have better solder paste transfer efficiency. Okay, but it's more expensive lah. It's more expensive. I think last time, okay, laser cut is only 600. Okay, so for electroform, the price maybe can reach until 1.5k, 1.5k, 1.5k until 2k lah, depend on the opening. Sometimes the vendor charge until 3k. But if we convert to USD, right, then it's nothing lah. 3k RM, then convert to USD, then customer still can pay lah. Okay, 600 RM only, what, $150 only if we convert to USD now. So but most of the time we'll order laser cut lah. Okay, laser cut. Laser cut also the lead time to produce is faster lah. If we order by this morning, right, so today evening or tonight we can receive the stencil already. But for electroform, I think maybe take 2 or 3 days lah. 2 or 3 days. Okay, so the turnaround is about 3 days. That's why we will choose laser cut lah. Okay. Okay. So okay, to design a stencil, okay, to design the stencil, okay. So this is all the information that we need to prepare lah. Usually I will get all this information before I start designing a stencil. Okay, the first one is a PCB Gerber file. PCB Gerber file is the PCB design file lah. PCB design file, the size of the pad, okay. Usually the important layer is the copper layer and silk screen layer lah, okay. We want to know the orientation of the component, okay. We want to know the pad is paired with which pad, okay. So that's why copper layer and silk screen is important lah, okay. And then component data sheet. Okay, component data sheet is because we want to know the dimension of the lead, the dimension of the component. Okay, so we know what is the type of the component, what is the type of the packaging. Okay, maybe it's a J-lead or QFM package or BGA or chip component O2, O1, O1, O5. So we can refer to the data sheet. And also some of the company, right? Some of the company have recommended PCB pad design. So if the designer did not follow the recommended design, right, and we cannot meet their expectation, then maybe we can ask the designer to modify the design of the pack. Okay, the third one is the BOM bill of materials. Okay. The fourth information is the solder paste type. Okay, we have type 3, type 4, type 5. Okay, type 3 is the normal lah. Normally we use type 3 now. Okay. Okay, the type of solder paste ni actually depend on the solder ball size. Okay, we have the powder size of the solder paste. So solder paste is made from the metal powder and a mixture of a chemical lah. So usually the composition is 50-50 lah. 50% solder powder and 50% the chemical composition lah. Flux, okay, flux and some of the other chemical lah, okay, that they mix with the paste. Okay, and then the SMT process, okay, the SMT process, okay, we want to run a clean process or no clean process. Okay, clean mean we need to wash the PCB. Okay, we need to wash the PCB after SMT to remove the residue and flux. And then we have another process, is a non-clean. So the SMT process also will define the type of solder paste that we will use, because clean and no clean solder paste will have a different type of solder paste because the chemical is different. Because sometimes if we wash, okay, if we send the PCB with no clean solder paste, then we will see a white residue lah after washing process. That's why we need to decide whether we want to run clean or no clean process. And then the last information that we need to have is the acceptability of electronic assemblies. Okay, which is the IPC document A610. Okay, 610. I think the latest version now is H. I believe it's H now. So we need to define with the customer whether class 1, class 2 or class 3. Okay, this one, okay, class 1, class 2 and class 3 will have a sometimes we have a different variation of the inspection criteria. Okay, so this one we need to discuss with customer. If they pay, if the product is critical, like chemical product, right? Okay, so maybe they will request for class 1. Okay, so general rule. Okay, general rule and assumption. Okay. Okay, this is what I learned from the senior. Okay, this is what I learned from the senior. Okay, the first one is the aspect ratio. Okay, aspect ratio is 1.5. Okay, 1.5. The spec is 1.5, and then we have the error ratio. Error ratio is 0.66. Okay, later I will share the formula lah how to calculate this. And then the third one. Okay, the third one is coming from the solder paste supplier. Okay. Okay, usually supplier will have the composition of metal powder and chemical inside solder paste is 50 to 60%. Okay, usually I will take 50% which means if I take 100 gram of solder paste, then after reflow volume by volume, I will only get 50 lah. 100, then after solidify, I will get 50 gram. Okay, that's my assumption lah. Okay. So the fourth one is a very optimum amount of solder paste that we print on the PCB pad. Okay. So this one is because of the, I think most of the time we have a problem with the, for chip component we will have a issue with the tombstone. Okay, tombstone non-weighting. Okay, so the force, okay, the force between left and right termination, well, we need to have a we want to make sure is a very minimum. Okay. Okay, too much space will result to greater torque pulling effect during solidify process lah. Okay, during reflow. That's why I always calculate a very minimum so the space required, okay, on each PCB pad. Okay. And then the fifth rule, okay, the fifth rule is the five solder ball rule. This one, okay, this one sometimes people will use 7 solder ball rules, okay, but most of the time I will use 5 lah, 5. So I will get smaller, okay. I can have a smaller opening lah, okay. Sometimes people will choose 7, okay. 7 also have, 6 also have, but common one is the 5 lah. Okay, common is 5. Okay, so I take some example. Okay, I take some example from the IPC. Okay, how I read the IPC specs. Okay, how I read the IPC spec. Okay, this one is a for chip component. For chip component. Okay, so the class 3. Okay, class 3 is the highest. Okay, class 3 is the highest. Okay, we have class 1, class 2, and class 3. Okay, this one is the inspection criteria. Okay. Okay, target, okay. Figure 8-32, okay. We can see, right? Okay, target class 1, class 2, and class 3. Okay, maximum fillet height is the solder thickness plus component termination height. Okay, this one is a very good one, okay. We have a very good fillet, okay. So the fillet does not extend on top of the body of the component, okay. And according to the maximum height of the component, and also we have a solder thickness, okay. Okay, solder thickness or standoff height, okay. That one is the target lah, okay, target. Okay. Okay, and then the acceptable, okay, acceptable, okay. Figure 8-33, okay, we can see, okay. Okay, acceptable class 1, class 2, and class 3, okay. Okay, this one, the spec is about, okay, maximum fillet height. Okay, maximum fillet height. Okay, maximum fillet height extend on top of the chip component termination. Okay, extend but does not touching the component body lah. Okay, okay, the solder just touching the termination only, but not touching the body. Okay, for like capacitor, right? Capacitor, okay, like capacitor, we have a metal termination, okay, and then we have a solder fillet, okay. We have excessive, okay, excessive solder. Then after reflow, the solder extend on top of the termination, but that does not touch the body. Okay, that one is acceptable. But defect when the solder touch the body of the component. Okay, extend, okay, which mean we have the termination, then the solder touch the component lah, not only the termination. Okay. Okay, so for fillet, okay, okay, fillet defect class 1 and class 2. No fillet height. Okay, no fillet height. Langsung tak ada. We cannot see any fillet. We cannot see any fillet. Okay, we cannot see any fillet. Okay, but for class 1 and class 2 does not determine the fillet height. Okay, okay, maybe 10% of the component height also. Okay, okay, that's not, we just visual, okay, we can see the fillet, then it's okay already. Okay, okay, so the spec does not tested the height, okay, the height. But for class 3, okay, for class 3, okay, for class 3, okay, we need to have, okay, 25% of the fillet height must be 25% of the component height. Okay, so if the component height, if let's say is 12, then 25% is 3 lah, is 3 mils, okay. So usually we will extend until 50 lah. So 50% easy to judge lah for the operator, okay. 25% not easy. So we always set for 50 lah usually, okay. So okay, same class defect, okay, figure 8-36, okay, defect class 1 to 3, insufficient solder. They want no fillet, okay, no weighted fillet is not evident, okay. Okay, so we cannot see any fillet, then it's reject already. Okay, so how I calculate, okay, how I calculate the solder paste requirement. Okay. Okay, this is example lah, example on O2 O1 component. Okay, okay. As we can see at the left side, right, day one is the PCB length pattern, and then at the right side is the component dimension. Okay, component dimension. Okay, example here. Okay, this is just example how I calculate lah. Okay. Okay, usually when the first time I join SMT, right? Okay, I calculate everything. Then I will have a library lah. So next time, if I want to design stencil for other PCB, then I will refer to my library. Okay, I will refer to my library. Okay, then I compare lah. Okay, example O201. Okay, before this O201 pad size is like this, and then suddenly this PCB, okay, the PCB pad is different. So I need to compare lah, and then maybe sometime calculate again, okay, calculate again the solder paste requirement. Okay, this is the example, okay. So okay, we focus on the pad size, okay. Okay, the pad size, okay, the pad size is a C, okay. Okay, we refer to the PCB length pattern. Okay, C is 12 mil, okay, and D is 13.5, okay. Okay, length is 13.5 and width is 12 mil. Okay, for component, okay, for component, we focus on the E dimension. E is the termination, okay, termination length, okay, and then the component thickness, okay, component thickness is 12 mil, okay, 12 mil. Okay, this is how I calculate lah usually, okay, for solder paste requirement. This is example, okay. So, okay, we refer to the spec, okay. So, we need to have a G, okay. G is the solder thickness, okay. G is solder thickness, okay. So, the first calculation is the standoff height, okay. I calculate that one first, okay. 11. So 11, okay. 11 come from where? Okay, 11 come from, okay, the termination length. Termination length is E at mils, and I plus 3 for the toe length, okay. I decide here, okay, the toe length is 25%, okay. Toe length is here, okay. You can see inside the diagram, okay, toe length is here. So I decide the toe length for the solder fillet is same as the 25% of the component thickness. So I will take 3, okay, 3 mils. Because the component height is 12 mil, so I will take 3 lah. So 8 tambah 3 dapat 11 lah, okay. 8 plus 3, 11, okay. Then 10 is the pad width, okay. Pad width is a component width lah, okay. Component width is 10, okay. I will take the component width is 10, and then 2 solder thickness. Thickness is 2 mils is a standoff height, okay, standoff height, and then I multiply with 2 because rule number 3, solidified solder is 50% volume of solder paste deposited. Okay, so this is how I calculate. So I get the 440 mil square. Okay. And then for solder fillet, okay. And then for solder fillet, okay. So I take 3. 3 is the toe length, okay, toe length, okay. And then 10 is the component width, okay. And then the thickness, okay, thickness is 3. This one is 3 is 25% lah, not 50. 25%, okay, 25%. Okay, actually this one is 25%. So I get 90 mil squared, and then I add up these two value, then I get the total solder volume required is 430 mil square. Okay, this is the solder volume that I need to deposit onto PCB pad. Okay, onto PCB pad. Okay, then after that I calculate the opening for the stencil. Okay, so this is the 430. Okay, so next slide is the 430. Okay, this is what I need. Okay, so this one I need to calculate, then I calculate based on my calculation. Okay, if I take aperture, okay, aperture for the stencil, square stencil, aperture is 12 by 12, and the stencil thickness is 4 mils. Okay, based on my calculation, I will get aspect ratio 3. So I meet rule number 1. Okay, aspect ratio is 1.5, and then error ratio is 0.75. Okay, minimum is 0.66. Okay, so you can see this is the error ratio at the left side. Okay, the formula for aspect ratio and error ratio. Okay, that's how we calculate. Okay, the aspect ratio and error ratio. Okay, simple calculation only. And then solder paste deposited is 576 mil square. Okay, it's more than 530 lah. So because we need to cater the solder paste transfer efficiency lah during printing, during stencil release process at printing station lah. Okay, that's why we need put more a bit only lah. Okay. Okay, so that's how I calculate lah. Okay, so that's how I calculate opening for the stencil. Okay, so this is just the example lah for O2 O1 component. Okay. Okay, I think that's all my slide for today lah. So if anything if any participant want to ask, then can ask me lah. Then I will try to answer if I can. Ada apa-apa nak tanya, boleh tanya lah dekat chat box. Then saya try jawab.
So Anwar, the library that you mentioned just now, so basically consists of all the width, height, all that, is it?
The stencil opening and the component type. Maybe not only chip component now, we have QFN, right? All we have all I will put inside Excel file lah. It's like my library lah. Then most of the time, right, the component is almost same, right? The dimension like QFN, BGA, everything. So if same, then I will just use first. This one is for me, right? The calculation is the first draft lah. Okay, we still don't know whether the design is correct or not, right? So this is the start lah. Maybe after that we need to tweak a bit the stencil design lah. After that, usually I will make 2 or 3 design lah. Okay, the first design usually is a try run. Then we will see the output after SMT reflow, whether it's good or not. Then from there we will tweak lah the design. We will do the DFM after that. Maybe sometimes the PCB pad is not correct, right? It's not suitable with the component, right? Maybe it's too big. Okay, maybe it's too big. Then we need to feedback to the PCB designer. The PCB pad is not suitable for the component. It's too big. Maybe we design already. Then we will have a solder short. So we need to see whether the PCB caused the problem or the stencil opening or the solder paste. That's why the one is we need to monitor the result after reflow. After reflow.
Okay, thank you.
So kepada siapa-siapa yang nak bertanyakan soalan kepada penceramah kita pada hari ini, boleh type soalan anda di chat box ataupun boleh buka mikrofon untuk bertanyakan soalan. Bukan selalu kita boleh berprogram dengan individu ataupun mereka yang sangat berpengalaman dalam bidang ni.
Tak ada boleh tanya. Okay, kalau macam kadang-kadang macam komponen yang tak ada dimension, susah lah. Macam contoh J-lead, okay? J-lead, okay? J-lead komponen, okay? J-lead komponen sometimes kalau untuk permulaan tu, selepas reflow, saya akan buat dia punya cross section. Cross section, then measure the dimension lah of the solder fillet. Then calculate back and design a new stencil lah. Kalau dia punya, kalau result after solder reflow is not so good lah. Okay. Memang masa mula-mula kalau buat stencil selalunya saya akan buat macam tu. Okay. First design is just like a draft lah. Then we run one board or two board first. Then inspect the result after reflow. If not good, then we need to measure the solder fillet, okay? The solder fillet lah. The solder fillet after reflow under a scope lah.
So ada sebarang persoalan sebelum kita akhiri kita punya webinar hari ini? Okay, saya rasa itu perkongsian yang sangat jelas. Thank you very much, sir, for the informative presentation. Okay, sebelum kita bersurai, sebagai tanda kenang-kenangan kepada semua, boleh tak kita sesi bergambar? It means semua buka cam. Boleh tak? Yang lain? Tak apa. Okay? Okay, senyum-senyum. 1, 2. Okay. Sekali lagi. 1. Okay, terima kasih diucapkan kepada semua yang sudi hadir meluangkan masa anda untuk sama-sama mendengar perkongsian daripada teknologis Anwar tadi. Okay, kepada semua, sebelum bersurai, saya nak share link kehadiran. Ini dia, so boleh scan dengan QR code.
Feedback dan attendance form saya dah letak di dalam chat. Kalau sesiapa boleh tak dapat nak scan QR code, boleh klik link di dalam chat ya.
Kemudian pusat jaringan industri dan masyarakat UTM ada juga social media melalui Facebook page rasmi. Okay, siapa-siapa nak tengok more information, activities yang akan dilakukan di masa yang akan datang, boleh like dan follow page rasmi ini, ada juga dekat LinkedIn. Okay, apa-apa informasi ataupun program yang seterusnya akan diinform dan dipost di Facebook page rasmi ini. So sekali lagi terima kasih kepada semua yang hadir pada hari ini. Pihak kami sangat menghargai, harap perkongsian ini memberikan manfaat yang baik untuk semua dan dapat orang kata dipraktiskan di industri-industri di masa yang akan datang lah. Okay, sekali lagi terima kasih dan Assalamualaikum. Jumpa lagi.
Baik, terima kasih.
Terima kasih. Bye-bye.
Terima kasih. Bye-bye.
Bye.
Terima kasih. Bye-bye.
Sama-sama.